Okay. The thing with log properties are, depending how much you liked or dislike exponent properties, is how much you're going to like slash dislike log properties, because they're the same properties, just in reverse. So we'll see how that looks. So how much you like the exponents, you'll like this one. If you dislike exponents, you're going to not like this one. So let's do the first property. The first property is going to be the product property. Now remember, this is all in logs. So what I'm first going to show you is in exponents, but the rule itself is going to be the log aspect of it. So the first thing I'm going to show you is the exponent thing, and then I'll show you the logs. So in exponents, if you remember, if you had x to, let's say, the m power, and you times that with x to the n power, what would occur is that you make one variable and you would add the exponents. So x plus n, m plus n. That should feel familiar. We've done that. What the rule is for new, that's for us, is going to be that log mn, so log m times n, can be spread out to log m plus log n. So this m, if you want to make clear, m times n can be spreaded to adding. So notice how they're reversed. In the exponent, you multiply them and you combine them with adding. Here, they're being multiplied and you spread them out with adding. The exponents you combine with adding, logs you spread out with adding. So let's look at an example with logs. Let's say log 3xy because they're being multiplied to each other, you can what we call expand it into separate logs. So I can rewrite this as log 3 plus log x plus log y. So if you see from one log to multiple logs, that would be an expansion. You're expanding it. And then we'll do the reverse later, probably tomorrow or something, where we have this spread out and we'll condense it. But today we'll focus on expanding wholly. I'll take any questions on this. If not, I'm happy to go on to the next part.
Mr. Joel,
What's up, Alyssa?
when are we going to use it? It's like, what is this for?
What is like how the questions are going to look like, or how they use it in real life?
Yeah, no, like, how are the questions going to look like?
Looks like these examples actually. I could like show you the next page.
Mr. Chagall,
Yeah, what's up?
is the log raised log y? No, wait, never mind. Let's finish out.
Is the 3 where it says log 3, like is that a little 3 or a big 3?
Because this was a normal 3, it stays a normal 3. So normal size 3. And then Alyssa, you'll see the questions, it'll look like this, and we'll talk about each rule, but you'll just get one log and then you'll spread it into multiple logs. So you'll see how that looks like. But let's go through the notes first and then you'll see the examples and then we'll call it a day. Okay, we have our next rule. If we just did products, the natural progression is to do the opposite of products, which is quotients or division. Again, I'm going to show you first with exponents, and then I'll show you what the logs. In the exponents, if you had x to the n power divided by x to the n power, that would cause it to be x, and you would subtract the exponents. So m minus n. So n power, subtract them. So if you had a log where you had m divided by n, does anyone want to theorize what your answer is going to be in this situation?
Log m minus log n.
I appreciate it, Alyssa. Good. Log m minus log n. Good. So it just matches the same pattern as exponents. That's why I said if you knew your exponents, you'll have no problem here. So this is the new rule right here, the log part. And let's do an example. Now I'm going to purposely make a little interesting example. So let's say log 2x over y. So log 2x over y. This is kind of a cheating example because it combines both the previous rule and this rule, but it's very useful. Now, log 2x over y, those are the normal size ones. The 2 and the x, what's happening between the 2 and the x is being multiplied. So since they're in between being multiplied to each other, when you spread it out, you'll follow the product or the multiplication rule, which is log 2 plus log x. So that part will have a plus sign in between. But because 2x is the,
I thought it would be like log 2 minus log x.
no, because 2, it's on the top 2 times x. But what is actually getting divided is y. So in that situation, because y is in the division or the divisor we saw, it will be minus log y. Since y is the only thing that's dividing anything, that's why it's the only one that gets a minus sign. The 2 and the x are being multiplied to each other, so multiply means adding. Subtraction or division means subtraction. All right. Our last rule for today, our last property today, is the power property. This is where people get tripped up a little bit. Even though it is a simple rule, because it kind of overlaps with the product property, people get tripped up a little bit. So when in exponents, you had x to the n power, and it was raised to another exponent, like the n power, what would happen is you would multiply the exponents, m and n. So they'll be multiplied to each other. So if it was like x to the third power to the fifth power, it will become x to the 15 power. For logs, if you have a log, oh, there's no particular reason why this is capitalized one way or the other, so you don't have to feel bad about that. But log, if you have m to the n power, you guys have a question in class or everything okay? It would be
No.
okay. What would become is this n powered would go to the front, and it will become n log m. So that exponent n is going to become a multiplication to the whole log of m. Very important. The normal size letter or number is going to stay there while the exponent goes to the front. So only the exponent goes in front. So the normal number stays, the exponent goes to the front. And let's go to our example. Let me be consistent with this. Log. Let's have x to the third power, y to the fourth power. X to the third power times y to the fourth power. Now, our first step should be to separate the x and the y. That'll make our life a lot easier. So we're going to separate the x and the y. So I'm going to rewrite this as log x to the third, log y to the fourth. What's in between, because this is multiplication, will be addition. So I'm going to put an adding sign in between. So I just separated the x and the y. What now I can do is, because I have an exponent in a log, I have an exponent in the log, I can move the exponents to the front. So my final answer will be 3 log x plus 4 log y. And this would be your final answer in this case. 3 log x plus 4 log y. Here's the notes. I see some people taking picture of the notes. If you ask me, I literally will post the notes. I don't mind that. It's very important though, and very useful just to write down, physically write down the notes will help you remember it more. If you need a copy of the notes, you literally could ask me. I'll post these notes. I post a recording of the notes. I don't mind posting the notes itself. But writing
So
it down helps you remember. What's up, Alyssa?
Are you able to post last class's notes?
Yeah, I'll post everything in one shot. So you can see all the notes here. I'll just post it all in one shot.
Okay,
One-
thank you.
Okay. Anyone still copying down, or anyone has any questions on this? Tomorrow, Mariah. I'll be coming back tomorrow, most likely, unless something happens. We'll talk about it tomorrow. Yeah. All right. Let's go to examples. Now, these examples I have are going to be similar to the examples here. So I would like everyone to try it themselves. Everyone give an honest try to themselves. I'm going to give you 5 whole minutes to do all of these. So try this one yourselves. Mhm. Okay. Use the notes from the previous page to help yourself out. They're very similar questions. To be fair, I actually did not really intend it to be that way, but looks like I'm not very creative. Everyone should be trying this one themselves. Alyssa, I agree for the first one.
For number 2, did that say LN?
LN, yeah. So if it's a LN, you write LN for each one. If it's a log, you write log for each one. Nahim, good for the number 1. Mariah, good for the. Can you write what you got for that question you said? So I can see if you do know it. I just want to make sure. Perfect. Now, I'll ask you this, Mariah. If you're going to ask a question for number 1, good job, Nahum, on that one. But Nahum, just keep in mind, it says LN. So it should be LNX, LNY, LNZ, not logs, okay? And Mariah, for the first one, think what happens when you multiply them? What happens? What's the rule when you multiply them? And that will help you fix that up. Alyssa, good for the second one. Good for the second one. Good, Mariah. If that's true, rewrite it as so. I know there's 3 parts, so you're going to have 3 different things. Or 3 different logs, I should say. And Nahum finishes off with a rounding perfect. Good job. So, Mariah, the first part's good, log 5, plus what are you missing there? Log what? All right, I said it in accident. You're missing a log there. Give about a minute and a half more. If you finish early, great job. Alyssa, great job with number 3. No, Mariah, you were right. The one on top is better. Log 5 plus log y, but what are you missing? Eliana, you got the first one, good. What are you missing? Don't forget, don't leave out one of the variables, Mariah, on that one. Just make sure that ln, Eliana, it's ln x, ln y, ln z. It's different than log, so you got to put ln instead. Okay. No, Mariah. 5, x, and y are all independent to each other. 5, x, and y are all different. So 5, x, and y should all have their own logs. There should be no sharing between them. There you go, Mariah. That's how you get it. Each one gets its own log. Now for number 2, Mariah, ask yourself, what does division does, and then react to that correctly. Again, you still have 3 entities though, x, y, and z. Good, Mariah. Good, Eliana. Excellent. All right. So Mariah, pay attention. I'll do number 2 in detail for you. Number 1, there's 3 entities, 5, x, and y. So it should be log 5 plus log x plus log y. All right. So log 5 plus log x plus log y. Solid. This one, 2 things are different. One, you have an ln. So when you have an ln, everything gets ln. X times y is occurring. So x times y is going to be ln x plus ln y, because they're multiplying to each other, just like you did on the top. What's different though, you have a divide by z. Since you're dividing by z, you're going to minus ln z. So since z is a denominator, it will be minus or negative. And for the last one, 4 log x plus, because they're being multiplied each other, 3 log y. Okay. All right. Get that done if you're missing it. Because the next section I have to explain because they're a little bit tougher. And I want to show you what thinking you have to have for these type of problems. So we're going to go to the next page in like 15 seconds, essentially. If you were trying it yourself, you should have at least half the answer down. You probably just have to fix a minus sign maybe, or fix one of the entities. All right. Let's go to the next 2 and the final 2 for today. Let's talk about 4 independently, and let's see if we have time for 5 at the end. So let's get down 4 for sure at least. ln square root xy. This is starting to combine a lot of the previous knowledge we learned from previous sections into one. So number 4, ln square root xy. Now, if you know,
Square.
say that again, Alyssa.
Are you gonna square it?
You can't change the value for fun because there's no equal sign. It's not like I could do it to both sides. So I'm not allowed to just square it to get rid of the square root. Well, you don't like it. But you notice the square root is impeding us, and I gave you no rules about square root. Something we should remember, though, is that we can rewrite a square root as something else. I could rewrite a square root as an exponent. What would be the exponent for a square root? If anyone remembers, the square root exponent. I'll give you a hint. It involves the little 2 on the inside. What is the exponent for a square root? The square root exponent is 1/2, a fraction, 1/2. No, you'll see. Oh, is that for? No. So 1/2. So your fraction is, or your exponent is a fraction, and that's okay. Now, in this case, we have the exponent happening and then a multiplication on the inside. So what we can do is move the exponent first. So I'm going to move the exponent first. If you distribute the exponent, then separate it, you still get 100%. You still be correct. But I'm going to move the exponent first. So now I have a 1/2 on the outside. ln x y. I guess I don't really need parentheses for that. So x times y. 1/2 times ln xy. This 1/2 is multiplied to everything here. So I'm going to split this into ln x plus ln y. Everyone should see that's agreeable. I had this 1/2 here, but technically the 1/2 hit everybody. So I need a way to represent that I would distribute this 1/2 to everything. So this 1/2 is going to need parentheses. Because it's 1/2 times ln xy, I need to show it. It's 1/2 times ln x plus ln y. So I need parentheses. Big hint, if you have parentheses here, you're very likely going to end with parentheses there. So that's a big hint. If you have to write parentheses here, you're probably going to have parentheses at that. Now, I believe we got 1 more minute left. I won't force you to do this. The bell just rung, so I want everyone to have a wonderful day. I'll post a little bit of homework for this, probably very basic ones, okay? Otherwise, no problem. Have a wonderful day. Bye.
Thank you.
No problem. Bye.